This is 2001, question 10. 10 hasn't appeared. A car of mass m kilograms traveling along a level road, and there is resistance to motion. So we have a car going this way, and there's resistance to motion. So we have forces. So you know straight away you're going to be dealing with forces equal to ma to get the acceleration into this question. mkv squared is the resistance to motion. So mkg force, so we only have mkv squared as the force, so minus, it's going in the opposite direction, we have the force going this way, minus kv squared is equal to ma. So my acceleration in this case is just going to go be minus kv squared, and we know we're going to be dealing with, what are we dealing with here? Obviously v, car's traveling at 14, the engine cuts out, and 10 seconds after the engine cuts out, there's a lot going on here. The speed of the car is 7. Just make sure you can see the 7. Okay, well what are we dealing with? Time here. Seems to be dealing with time. So A is equal to dv dt. If you do not know that, you're not watching this video. So dv dt is equal to minus kv squared. Trying to solve for k here in part 1. So we are going to get dv over v squared, or dv v to the power of minus 2 d squared, or dv over v squared, whatever you choose. It's going to be equal to minus k. That's a constant, and we'll integrate that with respect to t. Put my integral in over here. On my bands then, obviously starting at 0 for t. Or if you read the question, obviously not 0 for t. When the car is traveling at 14 meters per second, the engine cuts out. So when the car is traveling at 14, that's what it's starting at, the engine cuts out. And 10 seconds after the engine cuts out, so we're dealing with t and 10. So my t, I can put in, I could leave this t to start with, but I'm gonna, it'll be 10 seconds later. What did they tell us? The speed is 7, so they've actually given us loads of information here. Okay, you've integrated v to the minus 2 before, it's going to become minus 1 over v, so let's have a look why. V to the power of minus 1, increase the power, divide by the new power, it's going to be minus v to the minus 1, and it's probably easier to write it as minus 1 over v. Do that off to the side, so we have minus 1 over v between 7 and 14. Can be a little bit tricky putting the numbers in the right places. That's going to be equal to kt. Don't forget your minus kt between 10 and 0. So on the left we're going to have minus 1 over 7 minus 1 over 14 is equal to minus 10k. So the left hand side, if they were both over 14, we'd have 1 over 14 minus 2 over 14, so minus 1 over 14. Both sides are now negative, so we can make them positive, is equal to 10k. So k is going to be equal to 1 over 140, we hope, when we look back at the question. K is equal to 1 over 140. The car travels a distance of s in the first t seconds after the engine cuts out. Show that s is equal to 140 times the natural log of this chi. So we're dealing with distance acceleration, so v dv ds is equal to acceleration as well, and you all know that at this point. What was my acceleration? Minus kv squared. Minus kv squared is equal to v dv ds. So we're going to get minus kv is equal to dv, I wrote dx, I'm going to leave it as ds, dv ds. So that's going to give minus k ds is equal to dv over v. And if we integrate both of these, and we're dealing with after the engine cuts out, so that was 14 seconds, wasn't it? My initial speed is 14, so that's what we need here. My initial speed is 14. That will give me the velocity in there. Needs to be a bit neater. Stick it in here. And then between S at the start, so we're going to get minus Ks. We could put between S and 0 is equal to, it's going to be the natural log of V between V and 14. So we're going to get minus Ks. Just to change the order of these natural logs, it's going to be the natural log of V minus the natural log of 14. And if we multiply by the minus, we're going to get minus Ks is equal to the natural log of 14 minus the natural log of V, which puts the 14 on the top. And the V on the bottom will be minus K, will be plus Ks. I'm actually seeing here, I probably should have left the V on top. I'll show you why now. So the answer here, e to the power Ks is equal to 14 over V. So V e to the power Ks is equal to 14. So to get V, it's going to be V is equal to 14 over e to the power Ks. And I need to bring that up and change the sign of the indice. So V is equal to 14 e to the minus Ks. So if I had left it as minus Ks is equal to the natural log of, sorry, up above that, the natural log of, that minus shouldn't be there, shouldn't it? This one. So from this one, minus Ks is equal to the natural log of V over 14. So I get e to the power of minus Ks straight away is equal to V over 14, and then you can just stick the 14 in front to save you doing all this nonsense that I've just done. But it is early on a Saturday morning. So now we have velocity in terms of S. So dv dt, we're talking about time here. What are we looking for? Car travels a distance of S made in the first t seconds. So we have velocity, which is dv dt. dv dt is acceleration, ds dt is velocity. That's 14 e to the power of minus Ks. So we need to, we're told t seconds here, so we need to integrate s and t. So we have ds over e to the power of minus Ks, so we're going to bring that up, is equal to 14 dt. So I can put the integral in here, do it one step, or tidy it up and say e to the power of Ks ds is equal to the integral, or 14 times the integral of dt. And that's the big T we're looking for. So on the right, we're going to get 14t minus 0. And on the right, we're going to have 1 over k. This integrates to be 1 over k e to the power of Ks. And we're looking for S between S and 0. S and 0. So that's going to be 1 over k e to the power of Ks minus 1 over k e to the power of 0 is equal to 14t. K was not a straight line. K was 1 over 140, wasn't it? 1 over 140. So 1 over 1 over 140 is 140 over 1. So that's 140 e to the power of Ks minus 140 is equal to 14t. Divide by 14 to get, well, I could divide by 14, but what are we looking for? We are looking for S is equal to, so we need here S on its own. S on its own, so I need to divide by 140, e to the power of Ks minus 1 is equal to t to be 14 over 140, so 1 over 10. So t over 10. So e to the power of Ks is equal to t over 10. Looks like we're getting there, plus 1. So natural log of both sides, Ks by the natural log of e, this seems to be taking forever, is equal to the natural log, nearly 10 minutes. Maybe it's just me. And then we have k again, 1 over 140. I'm going to have to do this again. And we know the natural log of e is 1, so 1 over 140 times s is equal to the natural log of t over 10 plus 1 multiplied by 140 to get s is equal to 140 times the natural log of t over 10 plus 1. 140 by the natural log of t over 10 plus 1. Please God, 140 by the natural log of t over 10 plus 1.